And today we will switch topics, switch gear, and start to look into the language that if you want to work in the topic of like computer system, operating system, distributed system, high performance computing, computer architecture, compiler, anything that's not like front end and back end technology, but it's the technology that support, like it's the pillar of computer science, right? That support everything you do. Like people who somehow magically built this tools for you. C is a gateway for that, right? And that's one of the main reason why every single CS degree everywhere will teach you this language. It's an old language. It's a really really old language, but it's effective. And we'll talk a little bit about why they're effective. But the first thing I want to talk about is what is a computer, right? So we kind of asked this question earlier, if I remember correctly. Sorry, it was 2 weeks ago. But if you think about it, right? When you buy a computer, what is in there are like computational stuff, right? That allow you to do the add, subtract, multiply, if, else, for loop, and all those things you put in your program, right? When you write a program, the computer is supposed to be able to do that. Then it should be to communicate between each component. Somehow I need to be able to access the file on my hard drive. Somehow I need to be able to connect to the internet, right? And get all the data that I'm downloading. And somehow I need to basically store my file, right? Everything that I work on, it should be stored in a file so that I can open them up later, right? Even games you're playing, right? So let's say you play Elden Ring and you don't like, how many people say you all play Elden Ring, right? Because that's what I got from like one of the first few classes. Many of you, at least. Am I wrong here? I think I recall that. Are you still here with me? Um, what if I say every time you play that game again, you need to start from the beginning? You probably, well, because the game is super hard in the first place, right? From banging your head on a monitor and banging your keyboard every like 5 minutes, you probably will stop playing, right? So that's the storage for you. So it allows you to basically store, right, progress of your work, of your game, and everything. Yes, similar to programming, right? Programming is, to be honest, can be crazily hard. It's like playing these really, really hard games, right? But then when you work and program something, it's not like you do it from the beginning all the time, right? You save the file, you have different version, and you do that with the storage, right? So that's coming back to the content of this slide in particular, is that there's also the storage elements. But if you think about it in the physical sense, right? These are just tons of bits, right? What does bits mean? Anyone here can someone type on the chat that um and tell me what does the word bits refer to? It's a unit of data, perfect, right? It's 0 and 1 that is stored in the storage, and 1 byte of data is 8 bits, right? Basically, that's give you the room to represent the number from 0 to 255 in 1 byte, right? And at the end of the day, you can somehow put a hammer on your computer. Don't do that physically, folks. But let's say you can crack it open, right? And zoom in to the tiniest elements of your computer. These are what are you gonna see? Things like transistor, capacitor, resistor, and wires, right? So this is actually one of the reasons why you need to go through like high school physics, so that you know how does resistance work with voltage input, and also how does the current get generated, right? Because these drive the components that you use nowadays. It's not just electrical circuit for your home, right, that turns the lights on or off. It also have like computer have also electrical circuit And you can think of 0 and 1 as the on or off switch, but we would combine like billions and billions and billions of those bits together and make sure it works for the logic gates that add the two numbers together, or a logic gate that would do a multiply, right? So if you think about it in another way, these are just a bunch of bits, right? That somehow would mean something. Anyone here ever wonder, right? So if you're wondering, uh, when you write a program, everything is on your screen, right? But anyone ever wonder how does it actually run? Like what happened? Like how does the electron get moved around? And somehow when you run a program, it spits out the data that you're supposed to run. Anyone actually try to think about it? It does sound magical, right? It does sound magical. And these are, I would put an analogy of, yes, logic gate manipulation. Everything is science. Science is black magic. But if you understand enough of those science, black magic becomes science. And it's a great thing about human, right? Because we try to learn new thing and invent new, not new science, but understand new frontier in science. This allow us to actually allow you to write program, link maps together with physics. Who would think about that, right? It's awesome. uh and to be honest, if you wonder how does a program that you run get translated to something like electron moving in each component, you're in the right place. Because in this module and in the next module, once we are familiar with writing code in C, I'll start to touch on how does the code in C change into assembly, and how does the code in assembly get run. And we'll expand more on that on the architecture module in the PCSA class, and even more on the so we do have a special topic for computer architecture. And I know that at least there's like 3 or 4 students who want to take the class. So if you have one of those, let them know. Once we have at least 7 people interested, we can open that class for you guys. I want to really want to spread the word. It's one of the big areas in computer science where no one in Thailand is working on it. I guess except me. So here's a computer nowadays. Have you ever seen this thing? Or anyone play with Raspberry Pi at all? You did. Awesome. Right? So how do you like playing on it? Like, do you think it's actually powerful? It is, right? It can you install Linux on it, right? And once you can install Linux on it, working on the Raspberry Pi gets a lot easier because you have the actual operating system, right? You don't have to rely on many of the like microcontroller anymore. You just say, okay, I have Linux. Linux would control everything on a Pi, and then I just provide program on it, which is awesome, right? I'm sure many of you've seen these things before. The GPU. Anyone use it to play games? Or anyone use it to mine cryptocurrency? So these are also another piece of hardware, right? That are programmable, right? And you can run it to do awesome things, right? I'm not gonna say mine crypto is that awesome. I have as someone who work in both computer system, computer hardware, and um I'm not an like I took like high school economy class, and I took like the first year undergrad economy class, so I'm not definitely not an expert in that front. But the idea behind cryptocurrency make no sense to me. It seems so inefficient and not it's not ready. Like the current form is not something that I think would make sense. Probably need like newer generation of this like digital like currency. And I don't even know if you need like to be decentralized, right? But in any case, I'm not gonna make arguments about that. You can use it in mine crypto. How about running machine learning workload, like train a model? Anyone try that before using like PyTorch and TensorFlow? Build a recommendation system. It's for AI, yes. So there's so many workloads in AI that would run pretty well on a GPU. How many of you get sick of the Netflix, the recommendation for you? How many of you here spend 30 minutes trying to find what to watch on Netflix? We all been there, right? Or not? Am I the only one who's been there? Like, you spend so many hours trying to figure out what to watch, right? But but right, that in the back of this engine, there's also a recommendation system where it try to figure out what movie or what series you would like to watch, right? Yeah, that actually works. You can do your own, like these are like Rotten Tomato is kind of like a human recommendation system, right? It do a review for you and it say, hey, if you like this genre, these are the good lists, right? But there's also an algorithm that allow you to think about what can I recommend to the user. It's like it would recommend things like movies for you. It would recommend ads that would show up on Facebook, right? When you browse through your news feed. I'm sure that's the same thing happened in Twitter and Instagram, right? Try to learn who you are and suggest what you might like, right? This can be done on the GPU too. In fact, right? For example, there's a paper, right, from Facebook, right? That talks about how do they train this thing in a large cluster because they have so much data, right? And yes, YouTube recommendation system is really, really, really good, and it's gonna get better and better, right? Uh, uh, it's the power of advancement in computer science in both the software side, like recommendation system, and the hardware side, where you build a better and better GPU, better and better cluster. Cluster is something that you might have seen in the movie, right? So this is the cluster from Lawrence Livermore National Lab in the US. And as you can see, what are these things? That the black thing that you see here. Anyone want to guess what's inside? It's a server machine, right? Sometimes we call this blades because it does look like a thinner machine that you can plug in to each slot on the rack. So each one of these is a rack, like it's the vertical thing, and then you put in the server blades in there. They are designed to be super reliable. They are designed so that you don't have to power off a lot, right? Imagine what if you don't power off your machine forever, right? Your laptop will probably cry and will go through the typical like blue screen mode and reboot itself, right? The server, like the system skill server, is cannot afford to do that. You can't just say, hey, something go wrong, I'm gonna reboot myself. You will probably yell at me, right? If the system skill server went down while you are coding, right? So that's a reason why they are built to be super reliable. Um, there's also things like your phone. This is a really really old one. The newer iPhone doesn't look like this at all, but the iPhone is also another really really powerful computer, and you can have things like a GoPro, right? Anyone owns a GoPro? So yeah, like these like action camera, right? It's actually allow you to do a lot of image processing and video editing on the machine. It does have yeah, poor man's GoPro. It does have a lot of great accelerators that would do something we call signal processing. Signal is basically what we can um, read from, right? One type of signal are images and video, and you can process those signal so that you can balance out the lights. You can kind of put the uh like put the image in the HDR format, for example. You can kind of figure and denoise everything, making sure it's not grainy, right? So these can be done with computer chips that go into the GoPro. But with all these things, right? These are advances in hardware, but as a user, by user I meant programmer. So as a programmer, right, you want more abstraction. You want to be able to program in C and make sure it works on all the devices, right? Would it be perfect if you can use Python for every single thing? You can use Python to program your phone. You can use Python to program anything on the you want to put on the web app, right? Or if you can use Python for the code that goes in the GoPro, right? That would be great, right? So in terms of productivity, more abstraction leads to better productivity. As a programmer, you can just say, I will learn one language. I'm going to be really good on that language and I'll program everything using Python. Can anyone guess what could have gone wrong with that assumption? What could be the trade-off? What could be the trade-off if I use Python for everything? Yes, performance is one big thing, right? But anyway, with abstraction, right? You sometimes there are things you don't want to know. For example, if I call a function, let's say anyone would, everyone here used Python before, right? So when I have a function call in Python, I don't want to know what instruction get executed. I don't want to know how that get converted to assembly, right? No, there's no need for you to know. If I run the same code on a different machine, you just want it to work. That's it, right? You don't need to kind of change the language. Uh, you also want to kind of most of the time stick with Python. It's a lot easier than Java and a lot easier to program than C++ and a lot easier to program than C, right? And probably much, much, much more easier compared to assembly, right? Anyone here? I don't think at this day and age, not a lot of people program in assembly anymore because we don't need to. There's advancement in compiler uh, and programming languages that allow you to basically stay in the abstraction but get the performance of something as if you run the program in C. Also, you don't want to use machine code. That's just like that's too far. Anyone know what's the difference between assembly and machine code? So what's assembly? What is an assembly language? Can someone try to take a stab at this? Yeah, something like a jump instruction, right? It literally is called instruction. It tells the computer to do this instruction, and it go like line by line by line, right? Machine code can go up to like make that signal a high value, right? Those are even more painful, right? You also don't want to control each transistor individually, right? Um, yeah, I know about that too. I know. So you can probably fill in the gap brain and F word, right? It's a funny program, but it does work. I'm not sure anyone would be programming in that language, but it's funny, right? But it works. You can actually make sure your new programming language is Turing complete, and you can program on them, right? So the question that we should ask is, if Python is easy and if C++, for example, is easy enough and is fast enough, why should you care about learning C, right? So I'm gonna ask a few what if questions, right? What if your code becomes slow? The code consumes too much energy. Why should you care about energy consumption? What type of computer would care about energy consumption? All right, there's a phone, there's a laptop. That's a trick question. Every single computer cares about energy consumption. That's a trick question. Why is that the case? Anyone imagine like for server, for example, let's say I have a data center. Let's say I own Google, which own a lot of data center. If I can save 10 watts, 10 watts, just a really tiny amount of power per hour. right? If I can save that much energy per rack, I can save a lot, right? What else? What if I don't care about power and how much power it actually need to consume when I program something? Anyone has the experience of like using like playing games on your phone and get really, really, really hot? Anyone had that experience before? Like it's all the time, right? These are actually one of the main reason is when it get hot. The reason is because the game requires the CPU and everything to work as hard as it has to work, right? And also send a lot of access to the memory, so every single component gets turned on, right? And when every single component gets turned on, you need to pump in more electricity, right, from the battery. And one thing you might have noticed when you have higher power, it generates heat, right? It generates the heat and it consumes so much battery. So the battery will go out faster, right? On your computer, there's this thing called power supply. So if you built a computer before, you also have to buy a power supply. Anyone buy a power supply before? Anyone had done that before? So if you've done it before, what do you have to select? Like, how do you pick? How do you pick the right power supply? Anyone look at the wattage, right? Check the motherboard, check the CPU, and check the GPU spec, and look and make sure not the amp, because the amp is always the almost the same, right? Because you have to control how much current you pump through each wire. Otherwise, you're gonna heat up everything. But the amount of watts, right? How many watts of the power supply that you have to buy to make sure that every component on your computer would run at, let's say, at that peak power and will not like crash, right? You need to make sure the power supply has enough wattage to supply the CPU, RAM, motherboard, the GPU. A quick trick is check the CPU. Usually is less than like these days probably less than like 40, 50 watts. And then check the GPU. That's the main source of power draw. And then more than half you're good to go. Right? But that also limit how much power you can consume. And again, when you run games on your laptop or desktop, it will consume more energy, right? What if you switch to a new computer, even if it's a new one, but your code runs slower? Anyone run into that situation before? You like buy a brand new computer, you run your old program in there, and it doesn't work as well as you thought it would have worked. Or your program just basically produce incorrect results. Or you run into system level bugs. This can happen. Operating system is a program. OS is a program. So what can come with writing a program? You can write in bugs, right? There can be bugs in the OS. That's why you have patches and you have Windows Update and everything, right? So if you run your system level bugs one time, yeah, those are written in C++. So you need to know the language. Your code make computer hangs. This can also happen, right? For example, if you train something on a GPU and you need to use too much memory that the GPU doesn't have, it will crash. It will crash, right? You can have a code that shuts down the computer, right? Knowing how computer really works can help, right? So one thing that I realize is to know how this magic black box that we call a computer, how it works, usually is beneficial, even though you are just a programmer and work day by day without touching the hardware. But it allows you to basically know if you run into certain bugs, if you run into certain error from the code, right? You have a better guess on what's going on. And another thing that I want you to understand is everything that you do is a data, right? When you run a program, when you run a program, the OS, what it does is it copy programs binary, like those ones and zero. They copy those to the main memory. Every single piece of data is also stored in the main memory. So if in the next class, I'll go through this again. This assumption is called von Neumann model. It's one of the most used model of how you run a program. The processor then accesses both the program and the data from the main memory to perform computation, to run the program, basically. So the high level example is something like this. Like you write a you write a code, right? Pick me a language. Can someone give me a language? Oh my god. All right. Nope, English doesn't work here in this contract, and don't use the Brain F language too. Oh, let's do that. Let's do Brain F. And you fill in the last three letter, right? Let's use that language. How do you run it? Because you said you used it before. How do you run it? Oh, yell at me. I didn't say the word though, so I guess I'm okay. I guess. You compile, right? So the next step is you have the code and then you compile. What does compile really mean? Well, what's wrong with those words? I mean, at the end of the day, right? People who are conservative can say I swear I say like words that I'm not supposed to say in a class. It convert to machine language. It actually convert to assembly, right? And now when you have assembly, think of assembly as the only language that the machine understand, right? Metrics. Yeah, not there yet. So this is your computer. So an analogy is when you buy a computer, that CPU only talk one single language. Your Intel CPU talk a language called x86. The M1, anyone owns a Mac or MacBook that has the M1 chip? If you're using that, it's a different language called ARM, right? These are actually ISA, instruction set architecture, too wordy. Just think of it as a language. There can be a language called x86. It can be a language called ARM. Each CPU speaks strictly only one language. Only one language. The assembly that you compile has to be for that computer. That's why when you have to port over the program that you can run on an Intel machine to the new MacBook that run ARM machine, what do you have to do? Can someone, for those of you who use the MacBook right now, what do you typically have to do? How do you run a program that is not written specifically for that MacBook M1 chip? Anyone heard of Rosetta? Yeah. So you would use this thing called Rosetta, right? Basically, this translate x86 into ARM. Think of it as a way to have a translator that hear one language spits out another language. And for those of you who use Rosetta, what is the main complaints about it? What would be the general like things that can annoy you when you use Rosetta rather than the native program written for ARM? it's slow, right? Because you have to rely on another like entity to do the translation for you. So one thing that can happen is it's slower if you don't write that program well enough. Like I mean the Rosetta program, right? You can have translation bugs as well, where you convert to another language and you run into this corner case where it's buggy, right? So this is something that happened when you think about, okay, I have a program that written in this one language like Python or Brain Elf, right? Or C, but then you use it on a different machine and the performance looks different. These things can happen. All right. Anything, any question before we move on to C? So I took longer than I expected. Uh, we'll do a demo toward the end after we cover C, like the really, really, really basic of C. But I'm gonna extend the in-class deadline from tomorrow to, well, I'll just say Tuesday because we have a long weekend. Um, but yeah, let's do a quick 5 minutes break. We will do a Q&A in the meantime about anything that you are curious about. I think it's a good point to do the Q&A for the content we just covered. All right. Do we have in class today? Yes, we do have in class today. And no, it's not due today anymore. I'll change and update the deadline because it's gonna require a little bit more work than like 15 minutes. All right. All right. The first thing I need to cover, right? Why am I putting you in the process of learning C? Will there be more bash in this class? Nope. That's all bash scripts that you have to do for the class. Uh, Not all gone. I mean, you have assignment one. Yeah. So, oh, everyone is like happy. Wait until assignment three when we do memory allocation, and then you all be like, "Can I bring Bash back?" They just cue the mood. No, it's fun. It's fun. Yes, it's not regular expression. It's like a totally different beast altogether. It's a different malloc. Yeah, if you use malloc, you used malloc before, then you can tell which one is more fun. So one of your friends said malloc is more fun than regex, and I do agree. I do agree. I mean, I've been programming in C++ and C for ages. So it's once you get used to it, it gets much, much, much better. In the worst case, you just run and say sequout and you figure out what's wrong. Um, and once you program for long enough in C and C++, you kind of see the pattern on your own programming. What's my favorite language? So I use Python for something that I want done quickly. I use C I mean C++, for my work. And to be honest, I also use C# before and I like it a lot. But I would say C++. And to be honest, I also love Rust, but I don't actively program in Rust. Do I use C? Yeah, I use C. C is probably the first language I learned, actually. That was back in high school. Uh, so the reason why I did that, so I've been, so anyone here been through this like computer Olympic thing that some high school student apply to and like go and compete and all those things? So I used to be in one of the earlier camps. I I didn't go through all the way because I play too many games and my friends are much better. Ajahn Kanat went through all the way to become like one of the candidates who compete in the world level. Oh, sports are good too. Sports are good. I mean, it is activities that I would say are useful, right? Uh, I wish I played more sports back in the day too. Anyway, so I use a lot of C. I use a lot of C++. I like C++ a little bit more. It's a lot more convenient. Unless I have to deal with embedded system, then C makes sense, right? Because you can kind of like get to the level really close to the hardware. Python is really, really convenient. Java and C#, I see those two are similar. I do program in both. I like C# a little bit more. In the fun part, we teach you Scala and Rust. I do like Rust a lot. I personally hate functional programming. Compared to things like C, but it does make a lot of sense when you want to get performance. And I think Rust is a nice middle ground, right? It works really well. It translates really well into machine languages, and I think the performance and how it try to allow things to be run in parallel is great. Golang, I've heard a lot of great thing about it. I never personally use it. So it's just something I never personally have used. So if I try, maybe I would love it. I've seen a lot of people love it. The database community use a lot of Go language, actually. Because I think I've heard it's pretty fast and it's pretty relatively easy to deploy, right? Definitely hate assembly, I think in general. But I think that's true for everyone. Like no one should have to program in assembly actively. But you sometimes you need to understand how the code's supposed to work when you read the assembly code. So anyway, why C is fast. So you not heard about it. C is always like the milestone for a language in terms of performance because it's pretty lightweight. It's not a lot in C that you can do. So it's fast. It's close to the machine. You have to do a lot of things manually. You have direct control over memory locations. That's what malloc and free comes in. For when your friend mentioned malloc and free, these are what is given to you. It's really good in terms of hand tune everything. That's actually one of the reasons why C is fast. It's minimal and it's clean. It's compact, right? It works well in embedded processor. For example, let's say I have a microcontroller to go into this thing. It's just my air conditioner remote control, right? I need to be able to hit the up and down button to change the temperature. I should be able to hit the fan button to change the level of the fan so that the controller over there in the AC can control the temperature, right? The microcontroller is a little bit pretty primitive, but it's more complex, and it actually does have its own logic, right? Unlike the red laser pointer, for example, here that I use to play with my cat, right? It's only an on and off switch. I don't need to program anything. I just hit the switch, and then my cat would run around, right? Yeah, no one here. So today is weird. There's no cat around at all. Maybe they'll come in. And the reason why I said it's compact, the microcontroller that has program for these things, they have a really small memory, right? So you want your program to be really small, otherwise it won't fit. It actually won't fit. You can't put your program in there. Why not C? Can someone tell me why should not I program in C? I think this is basically pretty obvious. It's hard, right? It's relatively human readable. You just need to get used to how to trace through a function call. And but yeah, I have to be honest, it's not as humanly readable as Python, right? And you have to kind of have to manually handle many things. But that is also is a disadvantageous as well as advantageous because you now can control all the low level stuff. So why not C? You have to manually manage the dynamic memory. We'll go over this later. We'll go over this fun thing later, right? Whenever I said fun, you can probably guess it's going to be something crazy. It's not object oriented, so you can't just create an object. You have another thing called struct in C that kind of works almost like an object. It's not an object, but C++ is a good alternative. Now you can use object, which is a great thing. So the combination of C and C++ would work really well if you want high performance. There are many ways to create bugs. And for most cases, you will realize in assignment 2 and 3, you don't have to be creative to have bugs. The bugs you have will be different from the shell lab, from the shell scripting lab. It will be a totally different type of bugs. This make more sense. This would make more sense, but it can also be equally annoying. Forgot semicolon at the end, compilation error, right? So these are some of the things that you want to be aware of. So let's go into this language. Function in C, similar to Java and Python. The function has what? It returns a value. You can also have the input to the function. For example, right? The other thing is the function are physically located in the memory. So whatever you write in here, when you run it, your DRAM has the functions code in there. Let's say you have int add here, A and B, right? What does the function do? Can someone tell me quickly what does this do? It just returns the value of A plus B, right? You have inputs A, the second input's B, and it returns A plus B. So let's say I want to add 5 and 8 together. How do I write this? In C, I can do this. Add 5 and 8. This would call the function. Don't forget the semicolon. Semicolon at the end of each line or each statement would say, that's the end of my statement. That's the end of what I want to do now. So don't forget the semicolon. Why we have it here, right? This would add 5 and 8 together and it return the value 13, right? Another thing that I want to point out here is each function, when you return something, in this case, what's the type of the input? What's the type of A? What's the data type of A? Int, right? It basically said the data type of A is int, is an integer by definition. So it's a mass definition of integer, right? B is also an integer. What is this? Why do I have the int in front of the function name? What is that supposed to do? It's the type of what you want to return, right? It's the type of what you want to return. It's the type of the output. So C would demand you to tell what type do you want to return. Otherwise, I don't know what to do. So make sure you have the return type. Make sure you put in the input type, and then you can do whatever in the function. All right. My next question is, if I have a bunch of function calls, how do I know where to start when I run a program, right? Where do I start when I run a program? In Python, let's say I have a Python code, a code that I write in Python. What would be the first line that get run? Whatever is at the top, right? In C, that's not the case. In C, the first line that the program run would be inside a function called main. So inside the file that you write code in C, right? After you compile, the first line that get run would be in a function called main. Inside your code, there has to be a function called main. And in this case, it doesn't take any input. When you compile, the compiler know by default, I am going to run this line, followed by this line, followed by the other line. All right, any questions so far? Can there be more than one main? Great question. No. No, because why? It's a name conflict, right? If you have another file that you can compile together to a function called main, and how do I know which one is the main? Let's say it's two files, yeah, but you compile them together. Still, because it's in the same, what we call namespace. I guess Garan, right? Since you're the last guy to type in the chat. How can I tell the difference if there's another student called Garan and you can't use last name? No ID, I guess. No last name, no ID, no nothing. The only thing I can use is just the name, and that name happened to be the same name. Can I tell the difference between the two students without looking or without? Well, you can't that become two different name, right? Garand 1 and Garand 2 become two different name. So yeah, Garand and Garand, right? High and low voice. Uh, too tricky. But those are also two different names, at least phonetically, right? I would pronounce the name differently, so it's two different names. So in this case, in this namespace, you can't tell the difference. So that's why you have to have only one main function, right? You can do a different return type. So that works for object-oriented program. So in C++, I get, well, I never tried that in C++. Actually, I'm curious. I don't think it would work. I don't think it would work because main is kind of like a special function where compiler would flag that as like the line I would run. So it's not exactly something you're gonna create an object out of, right? So you can't do that. So hopefully it's more clear now. Like you can't just have like two main functions because then I don't know where to start, right? If I compile them together, they have to have two different function names. The compiler would literally yell at you like, "Man, it's already defined here. I don't know what to do," right? So now let's move on to the data type, right? Like other language, C also have multiple data types that you can work with. Integer. What's char? Anyone seen this before? Can someone guess what does char mean? A character like A, B, C, D. Even new line is a character. Float, as the name suggests, is a value with the floating point value, right? So great question. Decimal. Does it have to be decimal? So let me ask. This is a great comment at the end of the chat. So can I represent everything here using decimal number? Yeah. So I think I would like to now separate, right? So we're gonna go into a more of the theory side of thing, a little bit beyond the scope of what I planned for today. But it's a great question. The data you have has the value, right? The data definitely have the value. And also has the type, right? One can be an integer type. One can also be a character type. For example, the value 65 in character would basically become the letter A, right? That's an ASCII table. Float can also have the value 1. It literally would mean 1.0, right? So each value has its type, right? Has its own type. And the data type just represents the value. So in value of 65 is the letter A in character. So can I represent 65 in binary? Yeah, right. I can represent 65 in binary. It's basically 1 0 0 0 0 0 1, I think. Yeah. So that's 65 in binary. Can I represent 65 in hexadecimal? Yes, right? In hexadecimal format, this is basically 4 1 hexadecimal. Actually, there's a trick. You just divide the binary number by a group of 4. So there's 0 1 0 0 0 0 0 1. Each group of 4 becomes that letter in a hexadecimal number. 0 1 0 0 is 4. 0 0 0 1 is 1. So it's 4 1 in hexadecimal. And you can do the reverse that way too. 4 is 0 1 0 0. 1 is 0 0 0 1. Then you get the same binary number back. Anyway, right? It's just a representation. Does the value change? Does the value of my data change at all? You are correct, right? No, it doesn't change. The value stay the same, 65, right? The value stay the same. So you can represent your integer value with decimal number 65. So that's the default representation. But you can force the C program to, instead of display the number 65, I want the binary, so it becomes 0, 1, 0, 0, 0, 0, 0, 1. You can also force this to be represented using a character that in that case would literally print out A. And you can also do the same thing with hexadecimal, right? So that's the concept behind format string. We'll learn about this in a few slides. C, the other thing is C only support basic data type, but you can define your own complex data type. We're not going to touch about how to define our own complex data type today. That's a topic for next week. But the key here is there's no Boolean, right? What does Boolean mean? Boolean means is a value that represents true and false. True and false. So in C, if you want to have the value false, it's a value of 0. If you want the value of true, it can be any non-zero, like 1, 2, 3, 4, 5. So those are all true. Those are all true. So let me ask you this. Yeah, this is quite low level, but once you get used to it, it's not bad. So we all here familiar with the concept of if else, right? If else. What if I do this? If 2 C equals 1 plus 2, else C equals 3 plus 4. So let's say this is my code. If number 2 inside the parentheses, C equals 1 plus 2, else C equals 3 plus 4. What is C at the end? It's going to equal to 3. Why? Because 2 is not 0, so that means it literally becomes if true, C equals 1 plus 2. And in that case, just run 1 plus 2. Right? So are we all with me so far? Basically, if you want false, put in 0. So if you want to do C equals 3 plus 4, this has to be 0. If 0, do this. Variable, you can declare variable in a similar fashion to Java and I guess Python as well. You can say int a equals 0, int bc, b equals 20, c equals a plus b. Pretty self-explanatory. Then you can assign value from the data size to another. For example, in this case, right, b is an integer, right? It's an integer. D is a long integer. So this is long integer. Long integer will be a bigger, it's an integer that can cover bigger range, right? So that you can have a really high number and low, really low number. You can then assign D equals D. So basically in this case, D becomes 20. And this allows you to convert the data type, right? Because the value status, yeah. When you go from range as long as larger than max and int, what would happen? Great question. So let me draw something. So let's say I have a variable called x, right? And I have another variable called y. Something goes in here, and let's say this is the length of y. This is the length of y. And then what I do is that I do y equal x. What would happen? So that's your question, right? What would happen if I do y equals x? So let me double check. That's your question, right? So what would happen? This thing get copied over here. This thing will be gone. So you lose data. So be careful when you convert from a bigger to smaller. Conversion from smaller to bigger is fine because I have bigger size data. It can cover that range. So basically these are all in binary, right? Convert everything to binary and you crop just whatever data fit in that new size. So does it answer your question? All right. So basically that's converting data type, right? You can convert data by the operation we call casting. So int a would make sure that a is now represented as an integer. But be careful before you convert one type to another, right? Let's say int a equals 12, b equals 5. What is a divided by b? 2. Yes, it's 2 because basically what you do is 12 over 5 is an integer, right? So that's the number 2. Float a divided by float b is what? This is 12.0 divided by 5.0. So what is the value of this? Wait, no, 2.4. If you said 2.0, go get coffee. Because what happened is now A got convert to floating point, B also got convert to floating point. The operator division, so this is division, right? The operator division works on different data type. In this case, the data type becomes floating point, so now you do the floating point division. Earlier on, the division here works on integer, right? So it would do integer version of the division. Hopefully it's more clear. The operation that you do would get tied to whatever is next to that operator, right? So that it apply the right type. And similar to Java and Python, you can do add two numbers together, increment, right? So b plus plus means that b is going to equal to b plus 1. Division, this is modular. Check if a equals b. Check if a not equals b, right? Make sure that you are aware a equals b and a equals b are different. All right. The first thing, a equals b is what? What would happen if I type in a equals b? You assign the value of b into a. And actually, in this case, what would happen, right? What would happen? It doesn't compare. The left side a equals b is not comparing anything. Then it return b as a result of the operation. But the equal, that's the comparison. So what would happen if I do this? If 1 equal, or a equal 1, c equal 1 plus 2, else c equals 3 plus 4. If by accident I do if a equals 1, what is the value of c? Yeah. No, actually, because a equal 1, basically now a is going to be the value 1. C is going to do, if a is 1, it returns a. A is 1 inside the if, so that basically becomes if 1, right? This is basically the same as if 1. If 1 is true, c equals 1 plus 2, so that's 3, right? Are you with me so far? Just want to double check. It's okay. If you want me to repeat this again, it's also okay too. I know I'm going a little bit fast. 0 is false. 0 is false. Non-zero is true. 0 is false. Non-zero is true. So in this case, it's if 1 is if non-zero. So that's if true. What if I change by accident again? What if I have this? What is the value of c? 7. Yes, because now a becomes 0. It returns 0, right? So c is gonna equal 3 plus 4, which is 7. Okay, awesome. So you are all with me, hopefully. You can also have a logical and bitwise operator. So logical operator would work with logical statement. The bang is not, right? And or, right? So let's say if a is less than b and C is greater than D. Basically, this literally will check if A is less than D and C is greater than D. Bitwise operator basically would do the logic operation on the data. So not A would literally flip every single bit of A. So let's say A is 1101. Not A is going to flip every bit. So it becomes 0, 0, 1, 0. A and B will do this, right? So let's say if A is 1101, B is 1111. A and B is what? Can someone tell me what's A and B? 1 and 1 is 1, 1 and 1 is 1, 0 and 1 is 0, 1 and 1 is 1. Right? You literally take each bit of A and that with each bit of B. A or B, let's say A and B are the same, right? It's going to become 1, 1, 1, 1 because 1 or 1 is 1, 1 or 1 is 1, 0 or 1 is 1, 1 or 1 is 1. A, X or B. So exclusive OR is a little bit unique. If it's the same, 1 XOR 1 is 0. If the bits are different, 1 XOR 0 or 0 XOR 1, that's a 1. So in this case, 1 XOR 1 is 0, 1 XOR 1 is 0, 1 XOR 0 is 1, 1 XOR 1 is 0. You can also shift. This is right shift and left shift. So we'll do more practice on this on assignment 4, actually. You can put comments, and so we're gonna go through that quickly because we'll kind of iterate through that again on when it close to assignment 4. You can put in comments by doing the 2/ or this thing. Right? So clear comment. You can comment your code. Please comment your code on your submission. It helps me a lot. You can also have the control structure like if, else, or switch case, such as switch A, case 1, case 2, right? So basically what does this do? Anyone here never seen switch case before? Let me know right now if you've never seen switch case before so I can explain what it does. Okay, awesome. Sorry about this. So switch case, what it does is it would first check the value of, in this case, variable A. Then it's gonna have a bunch of case, right? If the value match each of the case, so let's say if A is 1, what happened? If A is 1, is matched this first case, right? So it will first do B++. And then it would keep doing whatever like the next line tell you to do. So it would first do B++, followed by B++, followed by break. Break means stop. So in this case, if A equals 1, B equals 0, right? Then at the end, B is gonna equal what? It will first do B++. There's no break here, so we do B++ again. So B is gonna equal 2, right? If A is 2, B is 0. At the end of the day, what's the value of B? If A is 2, you would do case 2 here. So you do B++ 1. So in this case, at the end, B equals 1. If A is 3, B is 0, right? In this case, it doesn't match anything. You would do whatever is in the default case. So we go to default. So the value of B is 1, yes. Not 0. Right? It gets incremented once. So one more thing. The default is optional. You don't have to have the default. This is optional. When you have no default statement, basically, if it doesn't match any of the case, do nothing. All right, are we all clear? Case 1, oh yeah, sure. So when you do the case 1 here, it would keep doing everything until it hits the break. In this case, what are all the statements after case 1 until it hit the break? Can you type me that? So the first thing is B++, right? Is there a break? Or do I keep going? Yes. So it goes to case 2. right? Because it starts from case one, so it would first do B++. The program doesn't tell me to break, so I'll keep falling through because it's fall through. So it fall through case two. Oh, B++ again. I'll keep doing this. What's the next command? Break. Okay, done. That's why B is 2. All right, so hopefully it's more clear now. If there's no break, it will keep going down until the end of the switch case. What if A is 0 or 4? Then you go to default. You go directly to default. All right, so the next thing is a loop, right? A loop, as we might have known, a loop will keep doing something until whatever go into the middle here becomes false, right? You can have a while loop. You can also have a do while loop, right? So, for example, while I is less than 5, right? In here, it's basically, it can be do while I is less than 5. You can also do the break. When you have a break, basically that would break you out of the loop. If something special happens, you can break out of the loop. You can also do not breaking, but continue to the next iteration. So let's say you have a continue statement. It basically stops that current round of that loop iteration, then skip to the next one. All right. I would recommend you to play around with break and continue a little bit. But basically break means I get out of the loop. Continue means I move to the next iteration. Printf and scanf. So to print something to the standard output, which is right now basically your monitor, you can use printf. So you can do printf hello world, right? %d here is a format string. This is a special symbol that say I'm gonna print a number. %d is decimal, so I'm gonna say hello world and some decimal values. What comes afterward is the actual value you want to print out, right? So this will print hello world 10. To read from the standard input, sorry about this typo, it should be %a. To read from the standard input, you can use scanf. So scanf %d, scanf %d. It would read a number, decimal number, and put the value of that decimal number into the variable called a. The reason why we need ampersand, just remember if you use scanf, put ampersand. We will talk about this when we talk about memory allocation. All right, so let's keep it at that for now. To compile and run your code on the server, you can use the GCC command. GCC is a C compiler. So let's say you have a program called test.c. You can then do gcc test.c -o, that means the output name. This would create, for example, the file called output underscore executable, where you can then run /output executable. This would allow you to now run your program. All right, that's it for today. There's a manual standard library that you can use and a format string. We will talk about standard library a bit, right? Because I think because we don't have enough time to do the in class number 5. Would it be okay if I merge in class 5 for today and on Tuesday as well? Can I do that? So basically, you have more time to work on in class 5, and hopefully, you have more time on Tuesday to kind of go over some of the things that you might want to know before starting in class 5. So we don't start in class 5 right now. I'll first do a demo by doing a basic hello world, factorial, and Fibonacci. Is that okay? So basically, we'll skip in class exercise today. We'll do it on Tuesday. Right now, I'm gonna switch over to my desktop to do the demo. Should you use C? What should you use for C? I use Vim. A lot of people say VS Code work really well. So if you can install VS Code on your machine, that is another recommendation. Any of these would work. Yes, I would change in class 5 due date. Don't worry. If I didn't change that, let me know. All right. So it's demo time. I'm going to switch over. Okay. Okay. So can you still hear me? I just hit resume recording. So this should also be on the video. So let's do this. So I created 3 blank file, hello.c, fib.c, and factorial.c. So the first thing we'll do is hello world. One thing that I have to tell you is, C, when you write a program, many of the function calls are not magic. It's pre-implemented by someone else that create this library that you can use. So to actually include the library for you in the program so that it knows what to call, right? There's a statement called include, right? And then you can specify things like standard io.h, right? Standard io is the standard input output library. So to make a little bit more expansion to this would cover things like printf, scanf, right? This would allow you to basically print something to your monitor through the printf function. Without this, I'll show you what would happen if you don't have this line. Without the include standard IO, printf would not work. The computer, when you compile your code, it doesn't know how to print things. Again, we have the main function, right? Put the bracket around it so that you know that's the end of the function. How do I print hello world? Can someone tell me what do I do? What is a function call that I can use to print things? Printf, right? Don't forget the semicolon at the end. This parenthesis is the input to your function, right? What do I put in here? It's a text, right? Hello world. Format string, I want a new line. Right? I want a new line. \n means it would print a new line afterward. So that's it. Printf, right? So let us compile. Compile, we can do it using GCC. If you do GCC without anything, without specifying the output file name and hit enter, what would happen is it will go and compile your program and you see what's the new file get generated here. Yes. So without specifying the -o, right? So if I want my own file name, I can do -o hello out. Right. In this case, it would generate an executable called hello.out. But if you don't specify that, it would be a.out by default. Then I can run it. We will just say hello world, which is the same as hello.out because it's basically the same program, right? So if I go back to hello.c, right? Oops, sorry bad. And I comment out the include standard IO. Let's see what would happen. Let's compile. Let's compile this and see what happened. It would yell at you, giving you a warning, right? Let's say, hey, I don't know what printf is, right? In this case, it's a warning, which means that if I remove a.out and hello.out, right? And compile it again, you'll see that it actually would correctly generate hello.out because these are standard library and compiler know printf is in standard IO, so it would automatically do that for you. But in many cases, it will give you error. It will give you error, and it won't compile. Don't forget to add this thing then, right? Now let's go to factorial. Let's see. Okay, how do I compute factorial? Oh, yeah, sure. I can go back to hello file again. Yes. Any questions about this? Feel free to ask me any questions about this. Sorry. If I'm going too fast, let me know. I'm basically reading the text on a chat over here on the left monitor. Oh, why is the return type int? Yeah, there's no need to. I can do this. Void. Void mean nothing. It doesn't return anything. This would also work. Right? And if I run a.out, it would just also do hello world, right? In this case, if I do int main, one thing I can do right at the end is return a normal status, right? Return 0, which means that the program reached that line and return 0 to the system. Oops. And when you run this, it would actually internally return status 0. So you can actually add that as a return type. So any other question about hello.c? All right, if not, okay, great question. Can we do something like this, right? YA. Is that what you're asking? Oh, yeah, you can. In this case, you can change to void. And then when you do return 0, the compiler would literally yell at you, like, I don't know how to return 0 in a void function. So let's try this. Here. It would give a warning, you're returning a value, but you're supposed to return void, right? In this case, it's a warning, so it would generate the output anyway and would basically skip over the return function because compiler these days are really, really intelligent. It will fix this for you. But if it's like 10 or 15 years ago, you're going to get an error. So hopefully, does it answer your question? All right, awesome. So let's do factorial. By the way, in Vim, you can do :E and type in the file name. Hit enter, it would open the file. So you don't have to close and open it again. You can also do :E, hit tab to check out all the file inside this directory. See? And then I can open whatever file I want to open. All right, a good trick. The other thing I can do in Vim, Control W V. Control W would give you the ability to deal with different window. So I can do Control W, the right arrow to move here, so that I can type in here, right? Why do I do this? One thing I can do is I can open hello.c in this window. I can do Control W left to be back here. Then I can do Control W right to go back to here. You can redo and undo. Undo is hit the letter U. Undo, right? You can close this and go back to just the factorial, all right? I'm not asking you to remember any of this. It's just handy and it's all in the cheat sheet that you can find online, right? The thing is, once you use more and more Vim, it's actually really, really powerful. In any case, let's do factorial. So factorial of n is what? How can I define the function factorial? Is n multiplied by factorial, right? N minus one. No, that's Fibonacci, guys. Not factorial n minus 1 plus factorial. Yeah. So what do I do? How do I do this? So whatever, basically I want to do something like this, right? At the end of the day, I want to print the factorial of, let's say 10 is
%d, right? Some value that I am going to return. And I want to create a function called fact of 10, right? So basically that's all I want to do. How do I create a function? What should I do here? What should I write here? Help me, help me, help me, help me. In fact, right? Superbit, you are doing a great job. So you have this for me. Fact, make sure it's the same name. In A is the input, right? So what do I do here? Well, in theory, I think one thing I can do is this. Return, right? Return A multiplied by what? Just go with the function we have declared earlier down here, right? That's the mathematical representation of factorial. I mean, you can use a loop. For loop actually would be faster than recursion. But let's go with recursion for now. This is a direct translation from our mathematical counterpart. So I have factorial of A. What should I return? A multiplied by what? Let's go with the math function, right? Why is loop faster than recursion? We'll go over that whenever if we have the time. It's like 5 minutes time today, but we will definitely go over that if not to on Tuesday. It has to do with how C handle function call. And I guess in general, how programming language have to handle function call. So is this a correct solution? What can go wrong with this answer? Is this correct? It's gonna go infinitely, right? It will go to fact 0, fact 1, fact 1, fact 0, fact -1, fact -2, right? So it will not return. So you need a base case. If what? What should be our base case? 1, return 1. Else, return A multiplied by fact of A minus 1. Is this correct? Can someone tell me if this is correct? What is fact of 0? Factorial of 0? What's the value of factorial of 0? Yeah, right? So you want to maybe cover that case as well. So if you do if A is equals 0, right? Now you return 1. This is then fact of 10 is, I guess we can check that. I just checked Google quickly. It's the exact same number. Awesome. You have a better, slightly faster version of factorial. If A is less or equal to 1. In this case, you save one more function call. This will also be correct. Right? Awesome. I can also do a loop implementation as well for I equals 0. I is less than A, I plus plus, right? Sure, it's neatly organized. What I can do here? Sum equals sum plus what? What should I do here? Fill in the blank to get the correct factorial. Yes. Sum multiplied by I. Right, it will keep going up, 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 up until it hits the value A, right? Is that correct? So let's confirm if that's correct or not. Nope, right? All right, can someone help me fix this function? Yeah. So you said do this, I plus 1. Still not correct. Did it? Do I forget something really important? Yes. All right. I think this is a good exercise. I think I just keep like making sure I forget a few things so that you can debug my own code. Right? Now it's correct. But is it truly correct? What if I say I want fact loop of 0? That is also correct, right? Because sum of 1, we cover this. If a is 0, go in here, false, you return 1. So this is good. Can we declare int I in here? Right? Let's try. It works. You can also do that. An older version of GCC, you cannot do this, but in a newer version, you can. And actually, there's a benefit in doing this. In terms of compilation, it allows you to know that I would get used only in the for loop and not outside. So you can do additional optimization. All right, so are we done with factorial? I'm gonna keep the code up to the right. I'm gonna open the Fibonacci on the left so that I can port the code over. One thing I would do is copy the and internet is out. Yeah, definitely internet was out. Okay, now I copy the main function. I change fib to now it's fib of n minus 1, right? Plus fib of n minus 2. Just to make it a little bit more neatly, right? Fib of a, which now I would parameterize this. Okay, class, help me write this. I guess this will be your in-class exercise for this class, which everyone will get the full credit, and we'll go through this together. So how do I write this code? How do I write a Fibonacci function? What do I return? Okay, fill in the parentheses for me. Can someone fill in the parentheses? A minus 1 and a minus 2, and is that all? If, right, if a is greater, less than or equal to something, base case, fill in the blank here. Sorry. So what should I fill in? Thank you. What is XX? Yay, right? So we oh, figure 1 is 1, figure 2 is 2, right? Oh, is that? What is fib of 2? What is fib of 2? 2. Okay, perfect. I just want to make sure we are all on the same page. So let's do a fib of 5, and we'll increase this number slowly, right? Are we done? Are we done? Let's confirm and try fib of 5. Thank you. This should be called fib, right? Are we done? Let's try. Fib of 5 is 8. Is that correct? 1, 1, 2, 5, 8. 1, 1, 2, 3, 5. Why is it 8 and not 5? All right, let's go in here and debug this together. Can someone help me? The reason is because fib of 2 is actually 1. So it's 1, 1, 2, 3, 5, right? Fib of 1 is 1, fib of 2 is 1, fib of 3 is 2. Yes. So over here, if a is less than or equal to 2, then you return 1 because you need to cover the case of fib of 1 and fib of 2, and both of them return 1. So this should fix the problem. What about fib of 10? 55, right? And I just have the confirmation to the left side of my screen. It is correct. What if we do fib of 50? Anyone notice how it takes for a while? It takes a while to do a fib of 50. It's still running. Still running. So it will eventually come back. Let's go back to our code and then decrease this number to 45. See, it still take a while, but it should come. Yeah, see? Function call in C is actually fast, but it's not that fast. So you notice how it's not like coming out right away. So let's change to 46. I think we're gonna hit the borderline where we don't want to wait soon. See how we increase by 1, but it gets a lot slower, right? So now change this to 47, and let's see how long we have to wait. It's actually not all about function call. It's actually also about how many, right? How many extra computation that, yeah, it's a lot. And now you also it's also loop around, so you just get a negative number, right? It is more about how many function call that you spawn using recursion. Think about fib of 47, how many randomly generated, not randomly generated, but through this function, fib 3 that get generated from fib of 47 compared to fib of 46. There'll be a lot more, right? Because fib of 47 would generate fib of 46 plus 6 fib of 45. So by default, fib of 47 first have to do fib of 46. And then compute fib of 45, which is a partial work that fib of 46 have to do. So it's a lot more work that you have to do because of recursion. And with recursion, the other thing is every time you call a function, you have to also do a lot of things, a lot of work in the main memory. That can also be long. Let's do a loop implementation. All right, let's do this and compare. All right, can someone help me through the loop implementation? Close. You can kind of skip that part if I equal 0. Sum equal what? 1. I guess we can do that too, right? If I equal 1, so that's it of just to make sure we keep our sanity in check. Let's start from 1 and go up to a. This is much easier. If I equals to 1, you do fifth of 1, that's 1. Fifth of 2 is 1, right? Else what? What is sum? So we need to kind of build the initial condition, right, for the earlier two number. This is called dynamic programming. So over here, sum equals to 1. Sorry, I'm gonna make a little bit of a mess in code here. I'm sorry, apologize. A is what? Just give it one line for the sake of our own sanity. Sum is gonna be a plus b. A is gonna be what? Yep. And then b is gonna be equal to a, right? But the order is a little bit off here because you want to do sum equal a plus b at the end, not at the beginning, because you want to kind of update the earlier number first, right? Am I? So which one is correct? How do I make sure this is correct? Do I do sum at the beginning or sum at the end? Or do I just make everyone super confused? Okay, quick answer, this. Yep, at the beginning. So let's trace through this code to make sure we are correct. If a is 1, what is the return value? So you want to return them. If a is 1, right? Simplest case, if a is 1, go in here, right? You return 1. And that's it, because I equals to a. If a is 2, you're going to return 1 as well. If a is 2, right, you return 1. If a is 3, sum is going to be a plus b, right? You first go into this loop. Then you go into this loop. A is 1, b is 1. So a plus b is 2. A equals sum. So a now is going to become 2. B is still equal a, which is 1. So let's confirm. And we definitely get an error. We doesn't know what to say. Cause we use the same name, so I will still flip of x here. See how this is wrong. All right, can someone tell me why it's returning 0? to check quickly. Let's start from A1. Okay. What about the value 2? So that's also correct. 2 is 1. If A is 3, it's 2. That's correct. If A is 4, that is when things get wrong, right? Why is that number 4? Why is fib of 4 is 4 and not 3? Fib of 4. Yes. Because otherwise, A equals sum, B equals A, it means B equals sum. Yes, thank you for catching that. Awesome. So let's try this again. Now it's 3, which is correct. Fib of 5 is going to be 5. Right? And then fib of 10 is going to be 55, which is correct. Now we have the functionality correct. Let's see how fast this is. Fib of 47. In recursion, it takes a long time. This is instant result. It's a lot faster, right? In module number 3, we'll also cover why this is a lot faster. The other reason why it's faster should be covered in the fun part class, but because I'm not sure if we actually would cover this specifically, we're gonna cover this when we will talk about module 3 again. Why is value negative? Awesome question. Remember how each number, like integer, for example, has a range? This is when the number go beyond that range. What happens when your value go beyond the range of what integer can hold? It go back to the negative maximum and go up from there. That's why the value is negative. So hopefully that answers your question. It's two complements format, yes. So basically, you think of it as you go to maximum and you loop around to negative maximum, keep going in the loop, right? So that's why the value is negative. All right. Any other questions? If we use scanf, how do we input in the terminal? Okay, that's awesome question. So let us do this. In A, and let's scan into A, right? Scanf. I want a number into the variable called A. Okay, so let's do this. Now it's gonna first wait for my input, right? So I can do type in 47, hit enter, and now it's fib of 47 is this. I can do this. 45, well, 458. Right? So I can now type in the number, hit enter, that goes into the variable that I just had. All right. Any other questions? So let me first stop the recording because